My name is Catherine Huxford, and today we're going to talk about supporting children in their maths conversations. How can we bring the maths to life with the CPA approach? So just a little bit of housekeeping. You might like to go to my camera and click on the blue rectangle in the top right-hand corner and click Pin Video. And that will mean that you can see me even when I share my screen. And can you just give me a thumbs up if you can see me? Has everybody got their thumbs up, Rachel?
The ones I can see, yeah.
Right, excellent. Okay, fantastic. So that puts, so I'm going to share my screen now. Actually, just let me bring up my presentation. While I'm getting this ready, a big shout out to my colleague, Pauline. It's nice to see that you've joined the session, Pauline, sorry, get your name right while I'm trying to do something else at the same time. And can you see my slideshow? Can you see my slideshow, Rachel?
Yep.
Great. So today we're supporting conversations and learning for all abilities, bringing maths to life with the CPA approach. This presentation was designed by myself and Margie Leach, who's not able to be here today. So the content of today is the supports that we're going to use for children are patterns, relationships, the CPA approach, and then we're going to look a little bit further at the exploration, possibilities, and illustrating strategies. So if you have a look at the picture on the right, you'll see that we have many balloons, and the task is to count them. But with this number of objects, there are lots of ways children could make mistakes. They could miss counting a balloon, they could forget, they could double count a balloon, they could forget the order of numbers. There are many complexities with counting. So we need ways to help children access all aspects of maths and not be held back simply by their ability or inability to count accurately. So how do we do this? We do it through pattern. So to find out how many, we're going to simplify this task by covering each balloon with one counter. And then here they are, all covered with a counter. And then we take the counters off and we put them into a pattern. The pattern of 10 on the left and the pattern of 6 on the right. Representing numbers in patterns that children can recognize without counting is a key support for their mathematical discussions. If they become familiar with the pattern for 6, for example, which many children are because of the dice, they can start to explore what makes up 6. We are wired to see pattern. Structured materials can help with this too, and I'm going to show you some later on. What are the benefits of using counting and pattern? Counters and pattern to simplify a counting task. So to summarize, pattern is an important support for mathematical discussions. We should be noticing patterns, describing patterns, and using patterns particularly structured materials that are based on patterns. The second point I want to make is the point of talking, exploring and using relationships. Have discussions about relationships even before you talk about numbers. What is the same? What is different? The language that you'll be getting out of the children is the precursor to discussing number. Without this language, big, small, bigger than, smaller than, it's really hard to understand what numbers are all about. What do you notice? What do you wonder? Discuss the relationship between these two. Which rod is bigger than the pink rod? Which one is smaller? Which one is longer? Which one is shorter? Which one has more? Can we find out how much more? What would we use to find that out? Value the discussion about relationships without number, and the children will start talking about number. How would you describe the relationship between these two shapes? The discussion about number should start naturally. Children will start showing you what they see and notice, and the power of children noticing will drive curiosity. Let's look at a word problem now. Ted has 4 toy cars and Ben has 7 toy cars. How many more does Ben have? Initially, we would launch this problem well. We would have a big discussion with children about what they think the problem is about. And we could hear if the children understand that this problem is about comparing 2 quantities of cars, rather than, well, what could happen even after launching the problem well, is that some children might have heard the word more and decide that it must be an addition of 4 plus 7, with 11 as the answer. Having lots of discussions about relationships can help prepare children for problem solving in groups. Having structured materials to show relationships will bring a visual understanding. Now we could get 7 cars out and 4 cars out, and that would be a valuable exercise. We could look at the difference here. We could count the difference of 3 or recognize 3 without counting by supervising. I'm going to stop sharing my screen now because I want to show what happens when you use structured materials. So when we use structured materials, something important happens. We have here a 7 and a 4. And if we compare these two, put them on top and compare them, we can see that the difference is 3 and that 7 has 3 more than 4. When you use structured materials a lot, the learners get used to the shape for the 7 and they get used to the shape for the 4, and it helps them move from not just solving a problem about the difference between cars, 7 cars today and 4 cars, and there's a difference of 3 cars, to discovering that the difference between 7 and 4 is always 3. And this is the aha moment. What I'm pointing out is that for some children, simply getting out concrete equipment and counting to find the answer might only help them find the answer to that problem. they might not see the relationship of that to any other maths problem, and definitely not to other real life problems. By involving the structured materials and recognizing that 4, for example, can always form this pattern and 7 can always form this pattern, they start to see that they can generalize about the relationship between 7 and 4. 7 is always 3 more than 4. Now, for our young learners, this discovery is the mathematical equipment, this discovery that this is always true is the mathematical equivalent of inventing the wheel. Let's look at it in another representation. You may be familiar with Cuisenaire rods. Cuisenaire rods are also concrete structured materials, and they're structured in a way that they're graduated consistently, and they don't have marks because they've actually been designed that this won't always represent 1. You can choose what it represents, and if this represents a different number, it affects the relationship with the others. But in this case, if this one does represent 1, then this black one represents 7 and the pink one represents 4. When we use concrete materials here, we can easily show that we're comparing 2 numbers. And one of the advantages is that we can see what we're looking for, this gap, what is the gap? And children start to realise that the answer must be a smaller number because we're starting to look at part, whole. And so that we start to see that we can explore what the problem is looking at through structured materials and not get confused and start to add. Right, let me go back to sharing my screen. So using structured concrete materials is my third point that helps support mathematical conversations. Let's look at another problem that uses larger numbers. This is not a level 3 problem. Kahu's family are going on holiday. They travel 240 kilometres on the first day, and on their second day, oh, sorry, I need to move this on my screen so I can read it. And 240 kilometres on their second day to reach their destination. How long was their journey? How long will the return journey be? These larger numbers are easier to represent with place value blocks. So I'm going to stop sharing my screen and bring out place value blocks. These are place value blocks. This is a yellow set. At school, you may have a blue set or another colour, or perhaps more commonly a wooden set. If you have to hunt for them, you might find that these small cubes are lost or missing, but you can buy replacements. The place value blocks work like this. The small cubes represent 1, ones, and the children should have time to explore that this rod, which has markings, represents 10. But you should let the children actually check that out and put 10 next to it to agree that 10 ones equals 1 rod. Similarly, 10 of these rods, 10 of these 10s lined up together will equal 100. And you can see the markings there. So we have a flat 100, we have 10 rods, and we have ones. So for this problem, we had 240 plus 240. And we can show that here with 200s. We can use 4 10s to represent the 40 and 0 ones. And then we want to add another 200s 240. 240 plus 240. And so we can show that adding it is easy, because now we see that the answer is, from the concrete materials, the answer is 480. I'm going to go back now to sharing my screen. Here it is in a pictorial representation. So with these diagrams, we can show 240 and 240, and that equals 480. There's the abstract there at the bottom. We can also represent it in a different pictorial way, showing the hundreds with 2 on the abacus, the tens with 4 on the abacus. Over the page here we have the pictorial leading into the algorithm. And you can see how it's linked in very easily. So this makes me ask, what's the big deal? Are concrete materials really important? Are concrete materials just for junior classes? Isn't it better to move them quickly to the abstract? What's the research about concrete materials? Rachel, could we run a little poll, our first poll? We've got a little poll for everybody. Be interested to know your answer to the question, do you use concrete materials a little, a lot, somewhere in between? Great.
Can you see the poll, Catherine?
I can see the poll. Yeah. Can everybody else see the answers to the poll? So we've got 21% say a little, 41% say a lot, and 38% say somewhere in between. Thanks, everybody. What about the second poll, Rachel?
Yeah, I can do the second. There's just a few comments in the chat with their answers vary depending on what year level they're talking about.
Oh, okay.
Yeah, so a lot with year 7, one person has said, and a lot with year 5 and 6. So answers may vary according to year levels, it looks like.
Fantastic. Well, if you're using materials, concrete materials a lot, then you're helping to support children. Here's a slightly different question in the second poll. How confident do you feel using structured concrete materials? So I've shown you 3 different types of structured concrete materials so far. I've shown you pneumacon shapes, I've shown you Cuisenaire rods, and I've shown you the place value box. So we've got 43, very confident. Oh, moving around. Somewhat confident, and a few not very confident. That's great. All those ones that are confident, that's fantastic. Okay, we might end that poll.
There's another quite interesting question, Catherine, about one teacher is teaching students via distance learning. And so using equipment is a bit trickier when you're doing distance learning.
That's really true. We do have some ways around that. Hopefully the child who's by distance does have access to some concrete materials themselves so that they can manipulate them themselves. All right, I'm going to share these results. So a lot of people are very confident. Quite a few people are somewhat confident. That's fantastic. Okay, and how do I get rid of that? How do I get rid of the poll? Oh, there it is. That's a problem on mine. All right, so I want to talk now about the CPA approach. Jerome Bruner's theory of development states that people learn best, abstract things best, when they go from the concrete through to the abstract. This is a three-step process called the CPA approach. CPA stands for Concrete-Pictorial-Abstract approach. For decades, educators have known the value of using concrete resources in children's early mathematics. Concrete resources go by the name of manipulatives. Let's have a closer look at these three typical developmental stages Bruner observed. This girl is actively learning about a real apple. She's touching and tasting it, understanding the rules of what the concept of an apple is. This concrete stage is a really important one, as everything else is built on the understanding at the concrete stage. The next stage is pictorial. And it can happen quite quickly that a child understands that a picture can represent a concrete object. This picture of an apple has some differences, such as it's a different colour and it has a stalk and a leaf, but it's the similarities that children pick out and connect this picture to the concept of an apple. The third stage is a symbolic abstract stage. There's nothing about this printed word apple, which is about to appear, which gives you any idea, has any link to the spoken word. It doesn't tell you, it doesn't give you a clue what it means. The third stage is symbolic and abstract. You have to understand the code of the language. Abstract symbols are an expression of our thoughts. The actual conceptual understanding of apple was formed at the concrete stage. Here's another example. This is a pictorial representation. There's enough information on it for us to realise which is female and which is male. Now, the representation on the right is purely symbolic. We would need much more information to know which is male and which is female. It's abstract. If you've been caught out by these symbols before, it's a good reminder. We need assistance with the abstract. Here's the CPA approach shown in relation to mathematical concepts. It is a gradual, systematic approach where each stage builds on the previous. But notice that we don't leave a stage behind. We make connections all the time. See, all the arrows are still present as you approach the right-hand side. Let's look from the left. Hone has one apple, Aroha has two apples. How many apples do they have together? In this example, children might handle real apples before progressing to manipulatives. When it's not possible to use real-life materials, multisensory manipulatives, such as pneumicon shapes, are used. This is often referred to as semi-concrete. A lot of time is spent on the concrete stage, as it's not until children have explored the concept that they can explain it. In the pictorial stage, children use pictures, models, or diagrams to describe their thinking. And this is a way of making mental images that help them in the following stage. In the abstract stage, students are able to use symbols such as numbers and math symbols to represent their thinking and solve maths problems. If we want children to have deep understandings in maths, then we will want them to make strong connections between the concrete, pictorial, and abstract representations that we use. A skilled teacher will flow between these stages to reinforce concepts and meet the needs of their students. And differentiating lessons becomes easier through this model. Learning is a continuum, and as students move through it, is at different stages and paces, and therefore it is important that a variety of representations are available and accessible at all times. In a CPA classroom, learners are not stigmatized for using concrete materials or pictorial models to explore and demonstrate their understanding. The Concrete-Pictorial-Abstract approach allows students opportunities to gain solid understandings of underlying mathematical concepts that lay a foundation for more abstract thinking. And this is a very big support for children in mathematical conversations, allowing them to have those aha moments. I'm going to continue on to my next point. If you want to use concrete structured materials, you need a time of exploration in order for the children to have a full grasp of what these structured materials can do. And by exploration, I really do mean exploration. In this one, the face has used the, they look purple there, the crimson rods, and the child will have noticed that they're all the same length. This is a mathematical representation of how numbers work. They will be looking for the smallest one to make the eyes and the nose. Children can have conversations and work together and explore the relationships between the objects. These are possible exploratory activities which don't need to mention number, but are demonstrating mathematical properties. So on the right-hand side, we have a pattern, a repeating pattern. We also, further over to the left, we see a staircase going up and down. It's actually a staircase showing 2, 4, 6, 8, 10, 10, 8, 6, 4, 2. So the consistency of that can be explored even before you explore the number components. The yellow pattern making a rectangle and the dark green one making another rectangle are examples of the exploration of equivalence. The one on the left is the yellow rod is often seen as a 5 rod if the white one is a 1, that's a 5. And so you can see different representations of what's equivalent to 5 done also in pattern form. Here we have some symmetry, and we have an exploration of the length of the rods. Now, this is interesting. These number tracks, because the rods are 1 centimetre in width and each one goes up by 1 centimetre in length. This, if you have a 100-metre ruler in your school with a track down the middle, that's actually been made for the Cuisenaire rods to sit into. The children can do a lot of exploration with these. This is some exploration with pneumocon shapes. You can see a lovely symmetrical picture there. An exploration looking at the quantity in the shapes covering the board, and this is a collaborative activity. Lots of discussion happening there. You could have a discussion with the children about what they see and what they notice. Have a look at this arrow. What can we see? What can we notice? There's a lot of discussions here. This is the exploration stage of using the apparatus. And I was talking yesterday to a teacher from year 6, and she said often as teachers we are in a hurry to get onto those really important mathematical concepts, but even for the older children, if they fully understand the breadth of what the structured materials can do, which they have learned through exploration, you get a lot more out of them. Here's some other children exploring and further counting. Now I'm going to stop sharing my screen and just show you something, another activity with using volume. So this particular activity focuses on volume, and in order to demonstrate it, I've made 3 cuboids out of Cuisenaire rods. This activity would start, this is for children in year 7 and 8 perhaps. This activity would start with the children making these cuboids, but in this instance I've made them to save time. This one we see has a width of 3, it's a 3 rod, it's got the width of 3, and it's got the length of 4 and the height of 5. This one here has the width of 4, the length of 3 and the height of 5, and this one here has the length of 5, sorry, the width of 5, length of 4 and the height of 3. So we're going to talk about that with the children and multiply out the different aspects to see, and we notice that the answer is 60 cubic centimetres and that the answer is the same for each of these. So we're going to think about, as we do this, we're thinking about the volume for each layer. So the bottom layer here is 3 times 4, and we see how the layers build up to build a solid volume. So here we have, this in fact is the same calculation but a different order. We can ask the children why this is so and see if they come to the conclusion that they are in fact the same cuboid, and if you turn this up this way you can actually see that more readily. So by exploring different cuboids and exploring other cuboids and with the other calculations, we can use the concrete materials, and from this exploration we want the children to ask themselves, is there a generalization to be made? How do we calculate the volume of any cuboid? So the volume of any cuboid is width times length times height, and that's what we're getting to at the end. The exploration of this has made it easier through concrete materials. All right. How are we doing for time? How much longer have we got, Rachel?
10:34, so you got another 10-15 minutes if you want.
Okay, I think that's fine. I will continue. So here we have the representation that I showed you. We can also show a pictorial representation and link it again to the abstract representation. So within the CPA approach, the deep conceptual understandings happen when the teachers flow between these representations and specifically show the links between them. All right, can we use Cuisenaire rods to show the proportions of juice concentrate and water to make up 12 cups? The ratio is 1 cup of juice concentrate to 5 cups of water. And then we have a further question. If each person drinks 250 mils at lunch, how many people are catered for? Show me how you would work this out. So if we use Cuisenaire rods to show the ratio, we could use the 5 rod and the 1 rod. I call it the 5 rod, but actually it can represent anything, but it is the equivalent of 5 of these small rods lined up. So on the top we show the 1 cup of juice concentrate, and on the bottom we show the 5 cups of water. That's the ratio that we have. For 2 cups of juice concentrate, we have 10 cups of water. So with this simple concrete representation, which I'm showing to you in pictorial form at the moment, we can then see 1 cup plus 5 cups equals 6 cups. That's the ratio. And when we put 2 cups, we have 2 cups of concentrate, 10 cups, and we have a total of 12 cups. If 1 cup equals 250 mils, which it does, then 12 cups are made and 12 people are catered for. Now, the exciting thing of what can happen here is if you teach children to use the concrete materials, they can actually then take that and explore other possibilities. What say we needed to cater for more people? How would we do that? And the concrete materials will free them up to be able to explore. You can imagine, you could look at catering for different people. You could ask, what say we used 20 cups, how many cups of concentrate would we need? They could easily use the manipulatives to show this. We could also look at other concentrates, perhaps that have a 1 cup to 6 cups water, or we have people that don't want it so strong. There's so many things that you can explore. Children have easy access to it with the concrete materials. So there's a balance of conceptual and procedural learning, and that's the success of using the CPA approach. This again is a good illustration of some of the structured concrete materials that I've explored with you. So the takeaways from this session are: use pattern. Give children an easy route into understanding number by representing different quantities in consistent patterns so that they can read them without counting and free up the cognitive load so that they can join in the mathematical conversations in your class. Talk about relationships. Bigger, smaller, shorter, longer are all prerequisites to understanding number. Looking at the difference, these concrete materials will help you look at the structure of the problem so that the children have a visual image. Use concrete, pictorial, and abstract representations and link them together. Don't stigmatize staying at the concrete stage or children getting out materials to demonstrate their understanding. Why do we do this? So that our ākonga will say, aha, I get it now. And then they'll say, let me show you how I know. And I can find other possibilities. And they can say, I can explore new ideas. And they can say, I can show you different strategies and why they both work. Thanks very much for coming today. Please stay for the Q&A. I would love to hear your questions, your comments. I think I love to talk to teachers about what they're doing in their maths classes. So I'm going to stop share now, and Rachel, do you want to read some of the questions? How do you want to run this bit? Oh, you're muted. Can you unmute yourself, Rachel?
Yeah, sorry. People are able to unmute themselves and ask a question in person, or you can put one in the chat line. That's totally up to you guys.
Somebody's mentioned MathBot. Yes, MathBot is a great online tool. Thank you for mentioning it, Sarah. And so if you go to MathBot, you can have, you can show, for example, the pneumicon shapes, and that's something you can manipulate them like an interactive whiteboard really, and show what you can do with those.
And Joyce has asked, do you recommend pneumicon? I don't know if you want to say a bit more about that.
Look, I'm absolutely delighted with pneumicon. So delighted I have a job that I can talk about it all day, but I actually love talking about maths, full stop. So with pneumicon, my journey is that I did always try to make maths real, but my first step was to improve my classroom conversations with problem solving, and that really helped the engagement in my class. But it was when I used pneumicon, and let me just clarify, I didn't just pick up the pieces and start to use them. I actually got the instruction manuals, and that's when I started to understand the real value of them. They are truly amazing, and I never had a child that didn't want to do maths. And the whole class was full of aha moments. So yes, I can highly recommend them. The actual pneumicon program uses Cuisenaire rods also, and obviously uses the place value equipment for the higher numbers. Got somebody asking about fractions. I think one of the things I say about fractions is that pizzas are not are limited in children being able to understand fractions. And so with the Numicon equipment, there is a certain aspect to maths that you can see with the Numicon equipment. I'm just going to show you one. So I'll just do it. For example, with these two shapes, I could show addition of 3 quarters, 3 of the 4, and 2 quarters, 2 of the 4. I can show this addition, and while I'm showing it with Numicon shapes, we see a representation of what the abstract symbols would look like, because we can actually see the 3 and the 4 represented, and the 2 and the 4. So we simply move this over to make, we say we've covered all of them, we've covered 1 whole and 1 quarter, and we can see the representation of the numbers with Numicon. Now there are other shapes that I've been exploring. I haven't got them here with me, but if you use hexagons with the pattern shapes, I don't know if you've seen them before, but you have trapezoids. I showed, one of the slides showed 2 red trapezoids making a hexagon and 1 red trapezoid. And the idea was that one was showing half and one was showing whole. So that's actually a really delightful resource as well. But it doesn't, it depends what you want to show. The Numicon really shows those numbers represented, and amazingly enough with Numicon, this astounded me, you can actually add with different denominators. You teach the children how to change the denominator even using Numicon, so right up to year 8. I hope that helps. That was a very quick answer. What are some other standout questions there, Rachel? Only got about 1 minute, I think.
Yeah, so lots of people saying thank you for the reminder about CPA. And thanks for the ideas about fractions. So I think it's just mostly people saying thank you very much for the session, Catherine.
Oh, that's great. Thank you, everybody. It's been a delight to see your eager faces on Saturday mornings. And I know that there's a whole lot of other people who'll be watching this recording afterwards. I put my email in the chat. It was also on the last slide, but for anybody who wants to get in touch with me, this is my job now, is certainly to assist teachers in this, and my email address is Catherine, that's CATHERINE @edushop.nz. And you can email me anytime.